Welcome to the next segment of High School Geometry with Netz and Weichel. I'm Mrs. Netz.
And I'm Mrs. Weichel.
Today we are going to be covering 1.2 angles. The learning target for today is, by the end of the lesson, you will understand how to think logically about solving problems with measurements and the relationship of different types of angles. Why do we need to learn this? Well, understanding angles helps you visualize different problems and helps you to understand when thinking the bigger picture in later chapters. I'll know I understand it when I can explain angle relationships and how to solve problems involving angles.
All right, let's get started. Our first vocabulary word is going to be, what is an angle? These notes are going to be similar to our 1.1 notes in that you have your term definition box, example box, and how to name. So please make sure you're filling everything in. In your first box, please write the word angle and then that it is a figure formed by two rays with the same endpoint. So if you remember from 1.1, a ray is a term where you have one endpoint, in this case it's B, going infinitely in one direction. In this case it's A. So we have ray BA, but then we also have ray BC, which is pointing downward. Together you have two rays sharing the same endpoint, so therefore we are making an angle. To name this, you are going to name it pretty much always with at least 3 points. You're going to put a little angle symbol, and then you're going to order the letters however you would like, as long as something called the vertex is in the middle. Your vertex is going to be the turning point for the angle. In this case, it's going to be letter B. So we are going to name this angle, angle A, B, C. Just like with lines and segments, you can name this in any order as long as the vertex is in the middle. So angle C, B, A is also an acceptable way to name this. If you only have one single angle using that particular vertex, it is acceptable to name this with just the vertex. But as soon as you have multiple angles using this vertex, you cannot do that, because if you have multiple angle B's, we won't know which one you're talking about.
Now, our critical point here, and you should absolutely make a side note, put it in red, highlight it, do something. Where the turning point is, or where the vertex is, always, always, always must be that middle letter. That middle letter is where the actual angle you are measuring is at.
Sometimes you will also possibly see a little number in the corner, like if there was an angle 1, that would be named angle 1. You may also see a little curved line here. That is also an angle symbol.
It just means that the angle has been measured. So the difference between having the arc on it and not having the arc on it, one is angle and one is the measure of angle 1.
And you could also see it written like that with a little M in front of it. So those are kind of special cases that you'll see when we're talking about the measure of those angles. Okay.
So let's talk about where this all comes from. Okay, if you think about it, a circle, most of us know and have accepted and understand that a circle to get all the way around is 360 degrees. So measuring an angle is commonly measured in degrees. We'll learn other ways later on in the course in how to measure angles. But for now, we're just going to be talking about degrees. And it is the distance that is completely going around the circle. So if we were to go all the way around the circle, we would say that it's 360 degrees. If I were only going to go 1 degree, then I would say that I went 1/360th of the circle, because there are 360 total degrees, and we're only talking about one of the 360. It is 1/360th of a circle. Now, if a circle is 360 degrees, If we were to go 2 degrees, then that would be 1/180th of a circle.
Why wouldn't it be over 360, Miss Nets?
Well, because actually, if we put this in the terms like we did our first problem, it would be 2 over 360. But we all know anytime you have something that is a fraction that can be simplified, we absolutely want to do that. So 2 over 360 simplified is 1 over 180. So our next one, if a circle is 360 degrees, then 7 degrees is 7 360ths of a circle. So what I'd like for you to do is just take a moment real quick on the next two. If a circle is 360, so you'll fill in 360 for both of them. But I would like for you to attempt to figure out what the fraction is, or what part of a circle that 10 degrees and 150 degrees are. So if you would, go ahead and pause the video, go ahead and figure out both those problems. When you've got them both figured out, unpause and you can check your answer. Okay, so let's go ahead and take a look how you did. So if we have 10 degrees, it would be 1 over 36 of a circle, or 1/36. Now, if you wrote 10 over 360, while technically it is correct, it's just not simplified. And both of those numbers are divisible by 10. So it becomes 1 over 36. On your next one, you may have written 150 over 360. If you did, both of those are simplified. Both divisible by 10, which becomes 15 over 36. Both those numbers are absolutely divisible by 3, so we get 5 over 12.
And then I went ahead and also showed you visually what that would look like on the circle. We know that a diameter here is going to cut a circle in half, making the 180 degrees. So going 150 would be just about that much of the circle. I just approximated it. And then for 10 degrees, I just went the other way around the circle. This would be about 10 degrees, or 1/36 of the circle. So that is what a degree is.
Awesome. So let's go ahead and turn the page. And this next page, actually the next 2 pages, is all vocabulary. And I think we pretty much told you on day 1 that geometry was going to be all vocabulary. So let's dive right in. First one, acute angle.
It's like an acute angle is going to be an angle that is measuring less than 90 degrees. I think some of these should be review for you guys. We know what a 90-degree angle looks like, hopefully. So we would like you in the example to go ahead and draw what an acute angle might look like. I have one right here for you. It is going to be a smaller angle. And when we talk about smaller, we are not talking about the length of the ray. Remember, a ray is infinite, so it doesn't matter how long you draw them. Okay? We're talking about the space between the rays.
Or the amount, think of it as the amount of how much it opens.
How much it's opening, the space in here. That's where we're referring to as far as smaller. So we're going to say that the measure of angle A is going to be less than 90 degrees. And then we're just going to basically go through the vocabulary words for classifying angles, just getting bigger. The next vocabulary word would be a right angle. A right angle has to specifically equal 90 degrees. It cannot equal anything else. We're going to show that it is a right angle by putting the right angle mark in the corner by the vertex. It's a little box. And we can say that the measure of angle R is equal to 90 degrees.
Now, if you ever see what looks like to be a right angle and the right angle marker is not there, it is very important that in geometry that you don't ever assume anything. Because while it may look like a 90-degree angle, it's very hard for us to just look at something and know whether it is 90 degrees or 89 degrees or 91 degrees. So if that marker is not there, do not assume
You can't use that they are 90 degrees.
that it is 90-degree angle. Or sometimes in the problem, in the context of the problem, they'll tell you this is a right angle, in which case you then could put the marker on the angle showing it is a right angle.
Or, vocabulary word from section 1.1, if two lines are perpendicular, you can put the right angle mark because you know perpendicular lines create those right angles when they intersect.
Absolutely. Okay, so our next one is going to be our obtuse angle. I have written a little side note in my notes saying that this angle is the big one. This is our big angle. It's going to be bigger than 90 degrees and less than 180, and we'll see why that is on our next vocabulary word. So on this angle, you'll go ahead and just always say that the angle itself is always going to be greater than 90 degrees, but always also less than 180.
So if we're talking in whole numbers, it can be anywhere from 91 degrees up to 179 degrees. Again, just speaking in whole degrees.
Perfect. So you could even write in your notes if you wanted to that this thing is going to be basically 90 point something.
90 point something up to 179 point something.
Yes, because it could go all the way to, well, actually, it'd be 90. Yeah, I don't even know how to get you guys to write it. It's bigger than 90.
It can't equal 90. It cannot equal 180. It can be anything bigger or smaller than those two, but it cannot be those exactly because there's no or equal to line. All right, the last one on this page, or I'm sorry, the next one, maybe new, maybe not, I'm not sure. It looks just like a line, but we're not talking about the length of the line drawn. We're talking about the degree in which the ray is rotating around to another side. So if you look at this, we're talking about from this ray to this ray. So we have a straight angle here, and that is going to equal exactly 180 degrees.
So important that you understand that a straight angle is not a line.
Not a line. They look very similar, but they are not the same. A line, if you remember from yesterday, or from 1.1, is infinite length going in opposite directions. A straight angle, oops, I forgot the vertex letter, S. A straight angle is this ray here and this ray here. So it's 180 degrees. It's like splitting a circle right in half. A vocabulary word that may come up for you, a straight angle is formed by two opposite rays. Two opposite rays. You have two rays going in directly opposite directions, which makes that line-looking angle.
So just know that with a straight angle, it's always going to have a measure of exactly 180 degrees. Your straight angle and your right angle are your only two that will use an equality sign and not an inequality sign, because they are exact measurements.
Okay, and now we're on to our last one, which may be a new vocabulary word. It's called a reflex angle. A reflex angle is going to be any angle that has a measure greater than 180 but less than 360. So we're not talking about the angle inside here. We're actually talking about all the way around out here. That's going to be your reflex angle. So the measure of angle F is going to be less than 360 but greater than 180. So similar to your obtuse angle, you have a range of numbers that are possible.
So your reflex angle, you can almost think of it as like when the doctor smacks on your knee and your leg kicks up. So it's going to, that angle that we're talking about is actually not underneath your knee. It's going to be kind of on the outside of your leg. Okay, so it's more than 90 degrees.
Okay, let's go ahead and turn the page. Now we're going to start talking about angle pairs. First one, we have a pair of vertical angles. Vertical angles are going to be two angles that are opposite each other when two lines intersect. So you have a pair of lines intersecting here. You actually now have two pairs of vertical angles. You have a pair right here, They're opposite the vertex. They're opposite the point of intersection. And then you have these pair here. Due to relationships that are formed and everything, what you need to understand with vertical angles, they're always congruent. Congruent meaning they are the same exact measurement.
Now, what I would like to see you doing from every lesson from here forward is every time you see a set of vertical angles, whether it's relevant to the problem or not, I would like to see you always mark them. So, to see the vertical angles, just know that when you have vertical angles, they will make an upside down and a right side up letter V. They could also make a V laying on its side to the right and a V laying on its side to the left. So you'll either see a right and left V, or you'll see an upright and upside down V. Okay? So when you see those, immediately mark them with vertical angles to show that those two angles are congruent. Okay?
So I'm just writing down that they are congruent. I went ahead and added in letters so you know which angles we're actually talking about. So this would be the perfect example of when angle C would not be a valid name for any of these angles, because you have all these 4 different angles are all angle C. So you have to use the 3 letters to name it so that we know specifically which angle you're talking about. So when I say angle ACB, well, here's A to C to B, so that's this angle here. We know it's going to be the same measurement as its vertical angle, which is right over here on the opposite side of that vertex, which would be angle DCE, because here's D to C to E. So those 2 angles are vertical to each other, therefore they are the same measurement. And then the same could be said for the other pair, angle ACD, which is ACD right here, is going to be exactly the same measurement as angle BCE, which is this angle down here on the bottom.
Okay, so our next vocabulary word that we are going to be doing is complementary angles. Oh, sorry, adjacent angles. I'm so sorry, I'm skipping ahead. Adjacent angles. Now, adjacent, the word adjacent means next to. So these are angles that are next to each other. They will share a ray. That ray will go from the vertex up through somewhere between the 2 angles. So adjacent angles are 2 angles with a common vertex and a shared side.
So you can see right here we have angle, I'm just going to say angle 1 and angle 2. Angle 1 is using these 2 rays and this vertex. Angle 2 is using these 2 rays and this vertex. You can see that this vertex is the same for angle 1 and 2. There's the common vertex piece. And then what I've highlighted in blue, that is a shared side between these 2 angles. So that is that common side piece. Both of those need to be true for angles to be considered adjacent.
Okay, so now back to our complementary angles. These are 2 angles that sum to 90 degrees. So these 2 angles will be either separate or they will be together. If they are together, you will be able to see that a right angle has been formed between the 2 angles. If they are separate, that may be a little more challenging to see.
So down here I'm drawing what Ms. Nets was just talking about. If I have a right angle and then I make them adjacent right angles, you now have 2 angles that are adding to equal 90 degrees. With these 2 separate angles, you would actually need to know their measurements. So let's say, for example,
so before we make a choice on whether these are complementary or not, we need to measure them and we need to know the measure of the angles. So we're going to actually use our protractor to measure them. To use your protractor to measure these angles, what you are going to do is you're going to put the center of your protractor at the vertex of the angle. And then you're going to take one side or the other, doesn't matter which, just depends on how you prefer to use it, and you're going to line up the bottom line that's going along the bottom of your protractor with one of the rays of your angle.
All of your protractors are different, so it is important that you look at where the center of your protractor is and where your line is for where 0 is.
And if you're having a difficult time finding where it is, just see one of us and we will be more than happy to show you how it works. So then what you are going to do is you are then going to see where the other ray on your triangle goes to on the protractor. So we're going to go ahead and take a look at this to get to that other ray. Make sure you're looking at the numbers on your protractor that start from 0 and count up, because on all protractors you can go both sides start at a 0.
So you can see the way that where I have this set up, my 0 is on the inside, so it's this inner set of numbers that are increasing from here. So if I look, here's 10 degrees, 20 degrees, here's 30 degrees, and 40 degrees. So I can tell on the lower set that I'm between 30 and 40 degrees. Now I'm going to go to the upper set. These little lines represent 1 degree. So if I know this is 30 degrees here, well, I'm going to count how many little lines, and it's right in the middle of that 30 and 40. So we're going to say that that is a 35-degree angle.
Okay, so, and you can measure these angles from either side, from either ray. I want to make sure everyone knows that. Okay, so we're gonna...
This one I'm actually going to use the other side because the angle's facing the other direction. So here's my vertex, here's the center of my protractor, so I'm going to line that up. And then I need to turn my protractor so that this 0, the 0 on the outside, is right on this ray here. So I'm going to go right to there. I'm going to stop.
Now, she could have made the choice, we're just going to show you real quick, she could have made the choice to line the protractor up with the other ray.
And then I would be using the inner set of numbers again.
Perfectly fine either way.
Just based on how it's facing, this one's going to be more right side up, so it's a little easier for me to see it. So I'm going to use the outer set of numbers so you can see this is what I'm going to be looking at right here. So I'm going 10, 20, 30, 40, 50. And, whoops. You can see I'm a little off. Here we go. Sorry, it's moving on me. You can see I'm a little off, trying to fix it. Here's 40, here's 50, here's 60. When we look right here, you can see that the other ray is crossing right at 55 degrees. So we're going to go ahead and say that this is a 55-degree angle. And we know that 55 plus 35 would equal 90 degrees, which makes these two angles complementary.
Excellent. Now let's talk about supplementary angles. Same exact thing. We would measure, we're not going to measure in this case because we know how to use our protractor now. So what we're going to tell you is we're going to go ahead and tell you the measure of these two angles. The larger...
You guys on your notes, though, could use your protractor to actually draw these measurements.
Absolutely.
Oh, no,
or actually, they could measure the angles that we have there. So on this first one, we're going to go ahead and tell you that it's 110 degrees. So this angle is 110. The other angle, the smaller angle, is 70 degrees.
And we know that 70 plus 110 gives me 180. So when you have two angles whose sum is 180, which we do here, we would say that these two angles are supplementary angles.
So therefore, absolutely going to be supplementary, going to be 180. All right.
Now, with complementary, we talked about how you could have two angles that are next to each other like this. They're adjacent angles with a right angle being complementary angles, or they could be separate. Supplementary, same thing, you could have separate. If you have two angles that are together forming the 180, you are going to have something called a linear pair. A linear pair is two adjacent angles whose non-common sides are opposite rays. So there's the vocabulary word again I talked about. So right here you can see that this ray is going straight to the left. This ray is going straight to the right. So this right here is actually a straight angle. Then in between them you have a common side, common vertex. So you have adjacent angles here forming that straight angle. making these two angles a linear pair. Linear pairs, if I say 1 and 2, we would say that angle 1 and angle 2 are supplementary because together they add up to equal what a straight angle must equal, which is 180 degrees.
Excellent. So when you are thinking of linear pair, look at the word linear pair. You see, first of all, the word line and linear.
Which we talked about, a straight angle looks like a line.
Okay, and you see the word pair, which means two. So linear pair means line two. So it's
two angles making what looks like a line.
Absolutely.
Literally, that's all it is.
Okay, so our last problem, or our last new word, is our angle addition postulate.
Which is very similar to a segment addition postulate from 1-1.
Basically, if you have two parts and you add the two parts together, they equal the whole thing. So, angle addition postulate, when two smaller angles are added together to equal a larger angle, is your definition.
So you can see here that ray YE is located inside of angle FYO. By drawing that ray, you are making new angles. Right here you have angle FYE. We can't name it with just Y because you have multiple angles using the vertex Y. So we're going to say the measure of angle FYE. Would you say that's a part or a total?
I would say that it's a part.
It's a part. And then you also, by drawing this ray YE, are making this new angle, angle EYO.
I think that's another part.
Angle EYO. That is another part. So because you have two parts, we are going to add them like the postulate says, and it is going to equal the total. And our total was the angle we originally had before drawing the ray inside, which was angle FYO.
Here is another great example, Mrs. Weichel, of why you can't name an angle by the vertex.
Exactly. You wouldn't know which angle to talk about.
If I talk about angle Y on this particular image, there are a total of 3 possible angles I could be talking about.
How would you know which one to add together? So that is the conclusion of 1.2 for angles. We are going to rate this however you want. Hopefully you're more towards green because most of this should be review. You need to know what an angle is. You need to be able to classify an angle, right, obtuse, acute. And you need to be able to use the angle addition postulate. Just remember again, you have to add two parts to make a whole. If you have questions though and you're not sure what to do, you need to message us on Remind, which everybody should have signed up by now, or you need to email us. Again, we have your email available to you right here for you.
Hey, Weichel.
Hey, what, Miss Nets?
Why was the angle freezing?
Why was it freezing?
It was less than 32 degrees.
Ah ha ha ha. Very funny, Miss Nets.
I know, I thought so too.
All right, thanks for joining us. We'll talk to you again.
See you next time.